Hello everybody, I'd like to talk about a new subject in statistics. It is regarding the calculation of the Spearman rank correlation coefficient. In a previous presentation, I have talked about the way of computing the Pearson correlation coefficient. And this is the second type, which is the Spearman correlation coefficient. The Spearman correlation coefficient depends on a data which are ranked in such a way. So, for example, for this question, we have the scores of 5 students in both math and English classes. What is needed for these data is to compute the Spearman rank correlation coefficient. And let's understand the rank before starting the computation of the Spearman correlation coefficient. From 90 till 100, we consider the rank to be excellent, while from 80 up to 89, it is very good. Between 70 and 79, we consider it to be good, while between 60 and 69, it is considered to be weak. So as you see here, in case of using the Spearman rank correlation coefficient, we are using the ranks of the data. We are not using a quantitative data, we are using what's called ranked data. So this is one of the difference between the computation of the Pearson and the Spearman. In case of Pearson correlation coefficient, we are dealing with quantitative records, while in Spearman we are using ranked records. This is the reason why the accuracy of using the Pearson correlation coefficient is greater than the Spearman rank correlation coefficient. Let's understand this point in more details. For example, regarding the math score, as we see here, the student number 1 and student number 2 have got 95 and 90 respectively. So we are not dealing with this score, we are dealing with the ranking of this score. So the rank for both student number 1 and student number 2 for the math is the same, it is excellent. Even so, the achievement of student number 1 is better than the achievement of student number 2. So this is one of the limitations of using the Spearman rank correlation coefficient. And again, for the same two students in the English, the first student have got 97 while the second one got 92. So as there are somehow some difference between the scores, they consider to be of the same rank, which are excellent. Let's say, for example, for the student number 5, the score of this student in the math is 60, while his score in the English is 68. So we consider the result for the math to be weak, and same for the English score, it is weak. Even the score in English is somehow better than the score in the math. So this point is the one of the limitation or one of the disadvantages of the using of the Spearman rank correlation coefficient. Let's again understand the way how to compute for the Spearman rank correlation coefficient, but with some details from other presentation regarding the regression line and the Pearson correlation coefficient and other things. First, we have this question. We have the price of 8 cars in $100 with different ages in year are in below table. So we have 8 cars. Of course, they are of the same model or brand. For example, for the car number 1, its age is 8 years, so the age is considered to be the X variable, while the price of this car is 45 multiplied by $100. For the second car, its age is less, it is 3 years, so the price is higher than the first one, it is $210, $100, and so on. So what is needed for this question? First is to display the scatter plot. Second, to find the equation of the regression line. Third is to draw the regression line. Then to compute the Pearson's correlation coefficient. Then to compute for the Spearman rank correlation coefficient. And this will be discussed in details. Then he asked to predict the value of y for both x equal 1 and x equal to 4. Then to compute the error of prediction for x equal 9. Then to compute the least square of the errors. And then to compute the sum of squares of error, SSE. But for an equation, not same like the regression line, y hat minus 36 multiplied by x plus 322.44. So first of all, this is the display of the scatter plot. The horizontal axis or the x-axis is the variable x, which is the age of the car, and regarding the y-axis, it is the price. Of course, the price is multiplied by 100 and the unit is the dollar. So as you see here, we have 8 plots or 8 observations for 8 cars. In general, you can simply conclude that the relationship between the age of the car, which is variable x, and the price of the car, which is variable y, is a negative correlation. Simply because as the value of x increases, which means that the age of the car increases, the value of the price of the car decreases. So this is the meaning of a negative correlation. We need now to find the equation of the regression line. So we need to have the new column for x squared and y squared and x times y, and have the sum of all these titles in the columns. This is the general formula for the equation of the straight regression line. The predicted value, which is y, is equal to the m multiplied by x plus b. M here represents the slope of the regression line. X is the value of the independent variable, which is the variable x, and the value of b is simply the y-intercept. This is the formula to compute for the slope of the regression line. We can simply substitute. This is n, this is sum of xy, This is sum of x multiplied by sum of y divided by n, which represent the number of observations. This is the sum of x squared, and this is the sum of x all squared. If you complete, you will find the value of m to be minus 34.44. So this is the value of the slope of the regression line. We can simply conclude that in case of a negative correlation between the two variables, the value of the slope should be negative. Same like what we get. So in this case, we find the value of the constant m. Now we need to find the value of the other constant, which is b, which represent the y-intercept. So this is the formula how to get for the value b, sum of y minus m multiplied by sum of x all divided by n. So this is the sum of y. This is the calculated value of m, and this is the sum of x, and this is the value of n. So if we proceed, we'll see that the value of b is 322.44. Now we can simply conclude the equation of the straight regression line, its y hat, equal minus 34.44 multiplied by x plus 322.44. Here the figure shows the regression line. As we see here, we have a negative slope, so we have a negative correlation between the two variables, which are the x and y. So for example, for the car with age of 5 years, which means that x equal 5, we have two values of y. The first one is the actual y, and the second is the predicted one, which is the point on the regression line. So for each value of x, we have two values of y. Compute the Pearson's correlation coefficient. Simply, we know the formula to compute for the Pearson correlation coefficient. We can simply substitute. This is n, sum of xy. This is sum x. This is sum y, divided by the root square of this is n. This is sum of x squared. This is sum of x all squared, multiplied by this is n. This is sum of y squared, and this is the sum of y all squared. So the value of the Pearson correlation coefficient is equal to minus 0.99. So in order to understand this value of correlation, simply we say that we have a negative correlation because we have a negative sign, and regarding the strong or the value of the correlation, it is 0.99, so we can consider it to be a very strong or strong correlation. So this is the interpretation for this value of Pearson correlation coefficient. We have strong and negative correlation. Now he asked to compute for the Spearman rank correlation coefficient. We will keep in this slide for more time. First of all, we have 8 observations, and we have 2 variables. We have the variable x, which is the age of the car, and we have the variable y, which represent the price of the car. So in this case, we add a new column for the rank of the age of the car. For example, the highest price for a car is the car number 5. The least age for the 8 cars is the car number 5, and its age is simply 2 years. So this car take the rank number 1. So after this car, we have 2 cars, car number 2 and car number 8. Both have ages of 3 years for car number 2 and car number 8. So both will take the same rank. But because the 2 rank is the same, so the second rank after rank 1 is 2 and the next is 3. So we have 2 and 3. So 2 plus 3 is equal to 5 divided by 2. So both, they will have a rank of 2.5, which is the average of the 2 ranks. So the car number 2 has a rank 2.5, and also car number 8 has the same rank, which is 2.5. So now we have the car number 6 with age of 5 years. So we finished in rank 3, so it will take rank 4. Then we have 2 cars with ages of 6 years, car number 3 and car number 7. So both will take the same rank, and the rank for both cars will be 5 plus 6 divided by 2, which is the average of the rank number 5 and rank number 6. So for car number 7, the rank is 5.5, and same for car number 3. Now we have the car number 1 with age of 8 years. So its rank will be 7, and the last car is the car number 4, which is the oldest car with 9 years age. It will have the rank of 8. So first of all, for the x variable, we make the rank same like what we have said. Then again, we include a new column for the second variable, which is the y variable, which is the price. So the same. The least price is 33, of course, multiplied by 100. It is for car number 4. So it will take rank number 1. Then after this price, we have the price of the first car. It is 45. So it will have rank 2. Then we have the car number 3 with price of 100. It will take rank number 3. Then car number 7, it will have rank number 4. Then car number 6, with rank number 5. Then we have the car number 2 with rank of 6. Then car number 8 with rank 7. And finally, the car number 5, which is the highest price. It will take the highest rank, which is 8. So this is the way how to make the rank for the price. Now we find the difference between the two ranks for each car. For example, for car number 1, we compute for D, and D represent the rank of the age, which is rank X, minus rank Y, which is 7 minus 2 is 5. Same for all cars, we count for D. Notice that the value of D, sometimes it is positive, sometimes it is negative. In order to obsolete this conflict, we take the square of this value of D. So we add the last column for D square. So we square all of the value of D, and finally we compute for the total or the sum of the D square. So this is the way how to rearrange the records before starting using the formula of the Spearman correlation coefficient. This is the formula how to compute for the Spearman rank correlation coefficient. R sub S, S here refer to Spearman. In order to differentiate it from the Spearman correlation coefficient, so we have R sub S is equal to 1 minus 6 sum of D squared divided by N multiplied by N squared minus 1. D square, the sum of D square represent here the sum of the square of the difference between the ranks. And regarding the small n, here small n represent the number of observations. We have 8 observations. So as you see here, the formula to compute for the Spearman rank correlation coefficient, somehow it is an easy formula in comparison with the formula for the Pearson coefficient. So this is one of the advantages of using the Spearman correlation coefficient. So now we can simply substitute. This is constant. This is the sum of D squared, 165. Number of observation, we have N to be 8 multiplied by N squared minus 1, 8 squared minus 1. So you can simply compute for the final value of the Spearman correlation coefficient to be minus 0.96. So if you try to compare this value with the Pearson coefficient, somehow they are close to each other with difference of 0.03. So in order to interpret this value of Spearman coefficient, we conclude that we have a negative correlation because of the negative sign. And regarding the value of the correlation or the strength of the correlation, we have a very strong correlation between the two variables, which means that as the age of the car increases, which means that as X increases, the price of the car, which is Y, becomes lower. So this is the interpretation. We have a very strong negative correlation. So this is the way how to compute for the Spearman rank correlation coefficient. The sixth part of the question is to predict the value of y hat for x equal to 1. see that the value of x equal to 1 is not included in our original data. So in this case, we can predict for the value of y for x equal to 1 simply by using the formula of the regression line, which is the line in red. So in this formula, we substitute for x to be 1. So y hat is minus 34.44 multiplied by x equal 1 plus 322.44. So the predicted value of y is 288. So if you draw a vertical line from x equal 1 till it intersect the regression line and take from this intersection a horizontal line, we have the y hat, which is equal to 288. So for a car with age of 1 year, the price of this car is 288, of course multiplied by $100. As you see here, x equal 1 is not included in our original range for x, because our range of x is simply between 2 and 9. So this process is called extrapolation. Another value to be predicted is the value of y for x equal to 4. See that x equal 4, we don't have a record for x equal to 4. So simply we can predict for this value, again by using the equation of the regression line and substitute for x equal to 4. So the predicted value for x equal 4 is 184.68. So again, if you draw a vertical line from point x equal 4 till it reaches the regression line and take from this point a horizontal line, we have the predicted value for the car of age of 4 years. Again, because the x value, which is 4, it is inside our range, we call this process in math to be interpolation. Now he asks us to compute the error of prediction for x equal to 9. Here for x equal to 9, actually we have two values of y. The first one is the actual value of y, which is already known from the records in the table. And regarding the second value, we have the predicted value on the regression line. So the difference between these two values represent the error of prediction, which is represented by the letter capital E. So the actual value, this is the actual value. It is already known. What is needed from us is to compute for the predicted value. So we can use the regression line formula and put for x equal 9. So the value is simply 12.48. So now we can simply calculate for the error of prediction, which is capital E, which represent the actual value y minus the predicted value. See that we will have a positive value for the error. The actual value for x equal 9 is 33, while the calculated or predicted one is 12.48. So the difference is 20.52, which represent the error of prediction. Now he asks to compute for the sum of squares of error, which is the least value. Of course, we call this sum to be the least because we will have the least value by using the regression line, which means that if we compute with different line, we will have another value of the SS for the error. It will be more than the least value. So the least value is the value using the formula of the regression line. So again, for x equal 9 here, we compute for the value of error. Actually, to compute for the error, we make the square in order to ignore the sign. Sometimes the sign becomes negative, sometimes it becomes positive. For example, for x equal 5, the value of the error will be negative, but anyway, we can ignore the negative by squaring this value. So this is what we are doing here. In this column here, we write the formula of the regression line, which means that for a specific value of x, we can find the predicted value of y. For example, for x equal 8, of course this is y, it's 45, but here we have the predicted value, which is y hat. So we substitute, instead of x, we write 8, so we have 46.92. So the value of the error is simply the actual value, which is the 45, minus the predicted value, which is 46.92. So we have minus 1.92. Then we have this last column, which represents the square of the error. So we square the minus 1.92, so it's 3.69. The same we should do for the rest of the observation. And finally, we should have the total sum of square. And this is the least value we can compute because our computation is based on the regression line formula. So the least square of error is simply the sum of the error squared for all the 8 observations, and these are the values of the squares of the error. This is for E1, this is for E2, and finally this is for E8 squared, and this is the least sum of square, 1500.36. See here in this slide, if we change the formula of the regression y, which means we have a new regression line or a new straight line, simply this line has a different slope from the previous one. Now its slope is minus 36, while the slope of the regression line is minus 34.44. And notice that the value of p is the same. See what will happen to the sum of the squares. The same here. This column represents the computation of the new predicted value of y with the new equation for the straight line. So we have this value, then we count for the error, then we square the error, and do the same for all the 8 observations and take the sum of the squares of the error. You can simply see that the value of the squares of the error becomes greater. The value is 2141.83. So this is not the least. The least, we have it by using the formula of the regression line. So this is the meaning of least squares of error. So the sum of squares of error is the same as the sum of the error square for all the observations. So as you see here, the value of the sum of the squares of the error becomes greater. That's all about the Spearman rank correlation coefficient and the, let's say, the topics related. Thanks a lot for your watching. If you like this presentation, please click on the like and don't forget to share or to contribute to my channel. That's all. Goodbye.